Welcome to this lesson on Euclidean geometry. Now, before we get started, I want to take a moment to celebrate you. Yes, you, for showing up watching this video. Even though there's so much other clickbait on YouTube, you decided to put your concentration and your extreme focus on this session and on getting better and improving your mathematics. So well done. Let's get started. It's my pleasure to help you. So first things first, what is Euclidean geometry? Well, it's a type of geometry where you use pre-existing laws, also called rules, to prove the value of angles or sides. Now, the goal of this type of geometry is to use a logical, correct chain of laws to prove a given scenario. Now, the requirement for this exercise is to know the pre-existing laws. But of course, we aren't all born knowing everything. So how do we actually get to know the laws? Through practice, practice, and practice. You want to first practice the laws separately to get enough reps in to really practice that. And then you can do mixed examples where there are multiple laws in the same question. Now, there will be a link in the description of this video to more practice. So please, if you are not sure of your laws, you need to know those first before we can continue. Now, these are the laws that you will need in the South African curriculum, and these are also used in the British, the US, and a couple of other curriculums as well. You can just double check in your own curriculum. And these are, as you can see, quite small over here. So what I would recommend is take a screenshot of this part of the video and just make sure that you find which laws are most relevant to your curriculum. Like, for example, if you haven't learned any of the or some of these, well, if the ones you haven't learned and your friends in your class also haven't learned them and you show it to your teacher, they haven't taught it, then it's safe to say that probably won't be in your exam. But all of the others, make sure that you know them very well. Right, let's carry on. Another important part of Euclidean geometry is to know the format of your answer. Every line of your answer, or 2 lines at most, must have a statement and a reason. Now, here's an example. The statement would be the what. In other words, what is the thing, the angles, the lines you are referring to? Now, over here, for example, it says angle E1 plus 2 is equal to angle C1 plus C2. Cool. Why? Well, because of angles in the same segment in this example. Notice that this is also shorthand for the original or full statement. The full statement being angles in the same segment. But you can also, and I would recommend that you get familiar with the different types of shorthand that you can use to save you some time when you're in that time crunch in a test. Okay, so that's it. Statement and reason. Make sure that you have those every two lines, but every line if possible. All right, now take a deep breath. You can do this. Celebrate how far you've come, and let's get into this session. Cool. Over here it says A is the center with points B, C, and D lying on the circumference of the circle. Line EF is a tangent to the circle at C, and it's given that C2 is equal to C3. Before we go any further, and I always recommend doing this first, before we go further, make sure that you fill in as much given information from this paragraph, this information. Fill in as much of it as possible onto your drawing. So they're given that A is the center. Okay, cool. C, B, and D lie on the circumference. Okay, now circumference, what on earth is that? Okay, make sure that's another thing. If you don't understand any words in the question, make sure that you actually get the definitions. Tangent is another bigger word over here. I'm going to explain them very quickly, but make sure that you revise them. Circumference is the line that is the outline of the circle. And tangent, this is a line that only touches the circle once at one specific point. And over here, the point is C. Okay, circumference, outline, tangent, line through one point. Cool, let's carry on. Now they say it's given that C2 is equal to C3. Okay, great. Let's just give them colors so we can see they're the same. Great. And then that's a tangent. Okay, cool. We know that. And then we also know that a line that goes from the center of the circle to a tangent is at 90 degrees. That is a rule given to us over here. See, radius tangent 90 degrees. Great. And another thing we know is that, let me see. Can we say that? Okay, no, we can't. And what I didn't mentally over there is something you can do too, is every single time you see a statement and reason, the only type of answer you can get that's true and that's correct is one that comes with a reason. So check yourself as you go. That's a great practice. Now let's go on with the rest of the question. They want us to answer, they want us to prove that ECB, in other words, this angle here, it's also angle C1, is equal to angle DCF, which is also C4. Okay, first things first, we just found out, or we just wrote in our circle on our diagram that angle C1 plus C2 is equal to 90 degrees. And again, the reason we used for that is radius is perpendicular to the tangent. So that is already what we drew in. We're just stating it in words. Okay, important that we state in words what we're drawing. And the next thing is the same. C3 plus C4 is equal to 90 degrees. It's equal to 90 degrees, and it's for the same reason, radius perpendicular to tangent. Great stuff. Exactly the same reason. So therefore, if this is true, then C1 plus C2, angle C1 plus C2, let's just shorthand it like that, angle C1 plus C2 is equal to angles C3 plus 4. Okay, and they're both 90 degrees. You can write that as your reason. Okay. Notice the reasons always go in brackets. But, okay, and whenever you say but, this is like saying I also know something else. It's given that C2 is equal to C3. Okay, you can see those are your blue angles in the diagram. C2 is equal to C3, and that your reason is that's given. Okay, so if C2 is equal to C3, right, those two are equal, but it's already 90 degrees as well, then the C1 plus C4 must be equal, because it's this already proven that the rest of the angles are the same. So right, therefore C1 is equal to angle C4, and then that would be your final answer. Or if you really want to, you can write it in the same, using the same letters that are given. So you can also write, therefore ECB is equal to angle DCF, and have that as your final answer. Okay, so that was a micro session on Euclidean geometry and how to apply it. Hope that helps, and remember to keep practicing.